Some hot aisle containment. Some of the benefits of hot aisle. Obviously, the same concept exists for partial or total containment. Same types of benefits exist. Try to keep that hot aisle from really blowing out into the main aisles and then wrapping around to the cold aisle, as well as a total containment, which incorporates a ceiling structure. Again, one of the reasons to implement the hot aisle, really all at that point when you do total containment, all the energy that is being used to cool your IT equipment is actually cooling your IT equipment. I mean, it's actually making it to the IT equipment, being pulled through the IT equipment, some rise of that temperature, and then directly back to your AC system. At that point, now you've had a closed loop system. You can start drive some predictability into that system and start controlling your set points to be optimal. It's not unusual to have cool air that is meant to be delivered to your IT equipment being set extremely low, 62, 65, 67 as a supply set point, not unusual. Why do they set it so low? Because they expect hot air to mix with it by the time it gets to all those different places in that undulating cloud, so they set it very low. Now that you have a predictability, you can start managing that temperature, and obviously if you don't need to drive your temperature very low, and you have a predictability in your system, you don't have to consume as much energy to bring the temperature down. Ideally, warm air is sent directly back to the AC unit, and your typical AC unit will actually be able to produce more kilowatts or tons of cooling with a higher temperature. You move up its performance curve, and then again, the predictability. This is just to give you a little bit of idea of a hot aisle. Integrates with the ceiling that I'd shown you before in the cold aisle. Essentially, you just take this unit, drop it on the aisle, connect up a return duct to your hot aisle, and you're off and running. You could use this in one location, two locations, or in every location, depending on how dense the heat was or in how much you needed to pull out of that aisle. But the same idea, physically bolts to the rack. So you have to move out the rack, you have to take this off temporarily, or brace it up and then move in another rack, if that's a requirement. And then it's made of clear Lexan. I've shown it here tinted, only because when I show this and it's clear, you can't see anything. Of course, it's fully adjustable, and you can use it as a cold air supply if you were dropping from above in the cold aisle. This is kind of gives you an idea of what that application will look like. End of row doors shown here, the cafe doors on a set of IT racks. And those cafe doors really just allow you to crash in, crash out. They don't lock. They're not meant to lock. You can make it a security environment if you wanted to have a different type of door lock. But this just gives you an idea of some of the flexibility. And then remember, we talked about everything we talked about is rack integrated. Here's a concept for the independent hot aisle. Brings a lot of different benefits. Ideally, the flexibility. Remember, I talked about the rack capability. Well, you can actually, with this type of system, support any type rack you want, any height, any width, any depth, as long as you're readjustifying to the hot aisle and maintain total containment. And you can move that rack in and out. We'll see here in a minute. But essentially, you take out a rack and put in a full rack size blanking panel without a rack there, meaning that the aisle is freestanding. Obviously, that facilitates add, moves, and change. If your adds, moves, and change on your IT level is to pull out an entire rack or test it in a test environment and roll out a rack, something like this may have interest. Again, cooling performance is achieved because you're maintaining that total containment environment. You don't have to worry about a chaos cooling and the lack of efficiency that you'd be able to gain with that. This really, in the end, all the heat containment is going to yield somewhere around the average of 30 to 35% cooling efficiency in your crack energy. This just gives you an idea. That's actually a freestanding aisle shown here with a variety of different IT racks connected up to it. Purposely shown, you probably wouldn't deploy it like this as far as that many different racks, really just showing the diversity of the equipment to be able to handle that. This is it partially deployed. So as you were populating a data center, you could pull out some of those vertical blanking panels, roll in a rack, and then over the top of the racks, kind of a Venetian blind concept that comes down and seals to the top of the rack to the hot aisle containment. Add chimneys as you like, and this row can grow as well. It's modular, scalable as far as containment goes, and the whole roof is clear if you don't have chimneys in it. So let's talk about some of the challenges. The hot aisle, go figure, is hot, and people don't like working in the hot aisle. Now, one of the things that it needs to be clear is you do have control over the hot aisle temperature, meaning it's not running rampant at some high level, meaning you can predictably and reliably control the hot aisle temperature. And you can actually say, geez, that I want to keep that temperature no more than 95. Well, that's not an unreasonable request. That's not an unreasonable temperature, really, to be working in. I mean, it's certainly an accepted ambient temperature, but again, perception, right? Of course, the local authorities back in here. Everybody here has probably dealt at some point with a local fire marshal. The local fire marshal may have something to say about this room inside a room and what its jurisdiction and how they are interpreting the codes. And make no mistake, the local authority that has jurisdiction, they have jurisdiction. And you need to work with local authority to understand what codes they're using, how they're interpreting them, and what their call is on any of these type systems. It is possible that if you're having a high dense load, the amount of chimneys that are going over that hot aisle may block a lot of ambient light. One of the benefits of having a clear ceiling is that a lot of that ambient light can get into the aisle and you have plenty of visual aid. Well, with chimneys, that may be blocked. Here's a picture of an actual system. Again, you can see the cafe doors. What we wound up doing here in this display was clear chimneys. I didn't have time to tint this one because this is an actual picture, but same idea, 6-inch blanking panels to move out. They wanted to be either take out a 30-inch rack and put in a 24 or vice versa if they had the room. So we had to go to a 6-inch vertical blanking resolution and make it seismic because it was freestanding.